Hey everyone, I welcome you all to this IBDP MAA HLSL course where we are going to cover all the topics and subtopics in this course, which are number and algebra, functions, geometry and trigonometry, statistics and probability, calculus, all 5 topics with their subtopics. You can find the playlist, okay? So be ready with your GDC. If you are in SL, so you will be having only paper 1 and paper 2. But if you are in HL level, you will have paper 1, 2 and 3. GDC is not allowed for paper 1 but yes allowed for paper 2 and paper 3. Okay, you can use your calculator for paper 2 and paper 3 only. So let's get started with our first topic, which is numbers and algebra, and its subtopic, which is SL 1.1, which is in both SL as well as HL. Okay, so here this is representation actually. We will learn how to represent our answer in the standard form. What is standard form? Standard form is when you write your answer in this a times 10 raised to the power k, where k is any integer and a is lying between 1 to 10. Its value can be 1 but not 10. Okay, so for example, if you have your answer as say 2.371 like this, what is that? Here this number is already in the standard form. Why? Because this number is lying between 1 to 10. So 2.371 is itself the standard form, but you can write it as 10 raised to the power 0 also if you want. For example, you have 23.731. Okay, this is your answer up to 3 decimal places. So in order to, it is decimal form. Now in order to write it in the standard form, you need to shift this decimal to left by 1 unit. So what that means, if you have to write it as 2.3731, then you have to take 10 raised to the power 1, because you are shifting your decimal to left side, then increase the power. For example, if you have 0.002731, in that case you have to shift your decimal to 3 places to the right. So your answer will be, again, you have to write a number which is lying between that 1 to 10. Its value can be 1. There is no problem with the 1, but can never be 10. Okay. So 2.731 times 10 raised to the power, since you shifted your decimal to 3 places in the right direction, so it will be -3. So in this way you can convert from the decimal to standard forms. Okay. Even if you use your calculator, there is a direct option to convert or write every answer in that standard form. But for those papers where calculator is not allowed and they clearly mention that you have to write your answer in this form, then only you have to convert it in this. Okay. Now let's do some more questions and see how can we convert from decimal to standard or standard to decimal forms. Okay. Let's get started with first one. It says Neptune is located 4.3514 times 10 raised to the power 9 kilometers from Earth. Okay, so this distance is given. Now you have to write this number in the decimal. So what is the power here? We have 10 raised to the power 9. It means we have to multiply this number with 1 and 9 zeros, right? So obviously your decimal will shift in the right direction in this case because you are expanding it. Okay, you already have the standard form. So what you can do, you can take 9 digits after this decimal. So how many digits are we have? 1, 3, 5, 1, 4. 4 digits are already there. So rest of the digits will be zeros. Okay, so I hope you got this. What you have to do is you have to write it as 43514. In this way you shift it up to 4 only, but still you need 5 more digits. So all those 5 will be zeros only. So this will be our answer in this case. Okay, so just shift it in the right direction and we get our answer as 43514000000. Next part. Next part is Nicole reads the number 8.03 e raised to the negative 5. What is that? It means 10 raised to the power minus 5. But in IBDP, this representation is not allowed. Okay, you cannot leave your answer in e power negative 5. No, you have to write it as 10 raised to the negative 5. Okay, so now it says write down this number in the standard form and express it as the decimal number also. So first let's write its standard form. So what we have? Already we have a number lying between 1 to 10. So 8.03 stays as it is. Only we have to change this one. So that becomes 8.03 times 10 raised to the power negative 5. Okay, standard form done. Now next is write the number in the decimal form as well. So we have to shift the decimal this time. What is that? Power is negative 5. If power is negative 5 and you are expanding it actually, so you have to shift your decimal in left direction. So you already have only one digit. So you need 4 more. So you have to take zeros. Then put a decimal. Okay. So at the end from here, you will get your answer as 0 point, then 4 zeros, then 803. In this way, you shifted your decimal by 5 units in the left direction. Next one. It says 1 grain of pollen weighs this much milligram. Now write the standard form. So what you are doing? You can pause the video and try this question by yourself also. Okay. So we have 2, 4, 5. 5 zeros over here. And we have to write it in standard form. So what we need? We need 2.5. But for that, we have to shift the decimal by 6 digits. Right? In the right direction by 6 digits. So what do we do? In this case, we have to write it in 10 raised to the power negative of 6. Okay, so let's write it. So we will get 2.5. Okay, it gives me 2.5 times 10 raised to the power negative 6 milligrams. That is the standard form. Okay, next part. One astronomical unit is 149,598,000 kilometers. The Voyager 1 spacecraft reaches a distance of 141 astronomical units from the Earth by the year 1998. Write this in the standard form in kilometers. Okay, so it's already in kilometers, so don't worry about that. But we have to find the value of 141 astronomical unit, where one astronomical unit is this much kilometer. So what will be the value of 141 astronomical units in the kilometers? Simply multiply these two quantities. Okay. First we need to multiply these quantities. Whatever be the answer is, that will be our direct value, right? Later we need to convert it in the standard form also. So let's do it. First is, let's multiply this 141 with 149,598,000. Okay, use your calculator and get the answer. This comes out as this much. Now we have to convert it in standard form. So it means we need to write it in 2.1093318. So I have to shift the decimal to the left direction. By how many digits? First count them. 3, 6, 9 and 10. So I have to shift the decimal by 10 digits in the left direction. So what I will get? I will get multiplied by 10 raised to the power that same number. That is the standard form for this. Okay. So 2.1093318 times 10 raised to the power 10 kilometers is the standard form. Okay. So this is the value for 141 astronomical units. Now, B part says justify the estimate that Voyager 1 spacecraft reached approximately 5 times as far from the Earth as from by the Neptune. Okay, so we need to find the ratio of these distances. If this is close to 5, then that's our answer, right? So for that, what can I do? I will take these two distances. Okay, so let's start with the first one. What is that? Here it is given Neptune is located at this much. So we already have that distance with us, right? From the Earth and the Neptune. Okay, so now let's start with this. So we already have the 141 astronomical units value, and we also have the distance of Neptune from the Earth, which is this one. So we simply need to divide these two and we have to check whether this is coming close to 5 or not. Okay, so for that, what we can do, we can just simplify it. We have 10 raised to the power 10, we have 10 raised to the power 9. So 9 powers will get cancelled, 9 powers of the numerator. So you are left with 1 power of 10 in the numerator over here. Then we still need to figure out this value. So we can also take its approximate value. That's also fine. Okay, if you want to, you can take the approximate value. So you can say this 2.10933318 something is almost approach, estimated value is 2, and this value is estimated as 4. Okay, now as I said, we are left with 2 by 4, which is again 1 by 2, and here this gives me 10 in the numerator. So what is that? 10 by 2. 10 by 2 is what? 5. Answer. Okay. So yes, we can say it is verified that the estimate Voyager 1 spacecraft reached approximately 5 times as far from the Earth as the Neptune. Okay. So that was all about the conversion from decimal to standard. Okay. Now, one question where this question needs to be converted into the standard form as well as in the decimal expansion. So here we have, it says number of cells in the human body are 37.2 trillion and 1 trillion is this much, 12 zeros are there, and an average length of cell is 10,000 nanometer and 1 nanometer is 10 raised to power 9 meters. So conversions are already known to us. First part says write down the number of cells in the human body and the average length of the cell in the standard form. So first let's find the value of number of cells in the standard form. Okay, so it is already given in trillion terms, so we don't use trillions, we will convert it in the standard form. So what we have, we will, in place of 1 trillion, I will write this number. So we will be having 37.2 times this 1 trillion value. Okay, so I have 37.2 times this value. So how many zeros are there? As I said, it is having 12 zeros. So instead of this, I can also write it as 10 raised to the power 12. But this is not standard form yet because it is having 37.2. We need to write it in standard form, means 3.72 we need. So for getting 3.72, again we need to shift this decimal to one place in the left direction. Okay. So in order to shift this to one place in the left direction, this power of 12 will become plus 1. Okay, so we will be having 3.72 times 10 raised to the power 13. These many cells are there in the human body. Second part, average length. It is what? 10,000 nanometer. So again we need to convert this in standard form. So 10,000 times this much, 10 raised to the power minus 9. So 10,000 nanometer means 10,000 times 10 to the power minus 9. So again I can write this as what? 10 raised to the power 4. So here we have 10 raised to the power 4 multiplied by 10 raised to the power negative 9. Since base are same, these two terms are in multiplication, powers will get added up. Right? So you will be having 10 raised to the power 4 minus 9, which is minus 5. Okay. So we have finally our answer as this, 10 raised to the power minus 5. But we need to write it in standard form. So I will write 1 times 10 raised to the power minus 5 for that. Right? Because I said you can have 1. Yes. From 1 to 10. 1 is included, 10 is not included in standard form. So this is average length in meters. Now B part says, hence calculate the length if all the cells are placed in a straight line. Express your answer in kilometers. So right now we have average length and total number of cells. So what we can do is, in order to find the overall length, see what happens is we have to place them in a line. Each of the cell have this much length. So there are 3.72 times 10 raised to the power 13 cells. So in order to find the total length, what can I do? I can simply multiply these two, right? So simplify it and we will get our answer. Let's do it. And later we have to convert it in the kilometer also, as well as in standard form. So let's start with this. Simply multiply these two. We get 3.72 times 10 raised to the power 13 times 1 times 10 raised to the power minus 5. So 3.72 times 1 gives you same 3.72, nothing. So 10 raised to the power 13 gets multiplied with 10 raised to the power minus 5. Again, base are same, powers gets added up. So we will have 13 plus minus 5. 13 minus 5 is 8. So we will get 3.72 times 10 raised to the power 8 in meters. Remember, this is only in meters. We need to convert it in kilometers. So what we already have the conversion, right? 1000 meters gives 1 kilometers. It means 10 raised to the power 3 meters is 1 kilometer. So in order to convert it in the kilometers, we can also write it as 3.72 times 10 raised to the power 5 times 10 raised to the power 3 meters. Right? 8 can be written as 5 plus 3. So this thing is what? Kilometers. Hence we got 3.72 times 10 raised to the power 5 kilometers as our final answer. I hope you get this. Still, if you have anything to ask, feel free to connect with me using this WhatsApp number, Telegram channel, or you can write it in the comment box also. Okay. Let's move to some more questions where we have to simplify the expressions and convert them in the standard form. Here, I have 3 times 10 raised to the power 10, 40 whole squared minus 5 times 10 raised to the power 80. So we need to simplify it without calculator. So let's first use the laws of exponent, which is a times b whole raised to the power m gives a raised to the power m, b raised to the power m same. So here we have 3 power 2 times 10 raised to the power, what is that, 40 power 2. Right? And if we have a raised to the power some m, then whole thing raised to the power n, that will become a raised to the power m times n. Laws of exponent. So here this 10 raised to the power 40 whole squared will become, this 3 square will become 9 times 10 raised to the power 80. Now the second term stays as it is, 5 times 10 raised to the power 80 minus 5 times 10 raised to the power 80. Now we need to simplify it further. So we can take out this 10 raised to the power 80 common from this, right? From both of these terms. So we have one term here, second term here. Take this out. So we get 9 minus 5 times 10 raised to the power 80. So 9 minus 5 is what? 4. So our answer is 4 times 10 raised to the power 80, which is our final answer. Okay. Next question. Evaluate 3 times 10 raised to the power n plus 1 minus 4 times 10 raised to the power n. Leave your answer in this form. It means standard form we have to write. So here what we have? We have 10 raised to the power n plus 1 and 10 raised to the power n. So we need to make the powers to be equal, right? So we can write it as 3 times 10 raised to the power n multiplied by 10, because this thing is nothing but 10 raised to the power n plus 1. But I converted it in 10 raised to the power n form. That's what we needed. Then 4 times 10 raised to the power n. Now 3 times 10 will become 30. So we have 30 times 10 raised to the power n minus 4 times 10 raised to the power n. Okay, same as the previous one. Take out that 10 raised to the power n common. So we have inside the bracket what, 30 minus 4. 30 minus 4 is 26. So is it the standard form? No. 26 is not allowed, right? Because we need to convert it in a number which is lying between 1 to 10. So we need to write it as 2.6. So let's write it as 2.6 times 10 raised to the power n plus 1, because we shifted our decimal in the left direction by 1. Okay. This is our final answer. Next one. This one is homework for you. What you have to do is try this question. Division sign is there. First, you have to divide these two terms and use the laws of exponent, convert it in the standard form at the end. Okay. This one is your homework. So I hope you got all these, and if you need any regular course, one-to-one tutoring or group sessions, feel free to connect with me. And today we have covered all the subtopics of 1.1. First, we started with this numbers converting using our calculator. Also, we can do the same as I said, or factorize, add, subtract. Yes, it is done, right? And use the laws of exponent to multiply, divide. We did this. We multiplied and divided also here. When we divide it, then we got 10 raised to the power 10 by 10 raised to the power 9 as 10 raised to the power 1 only. And if we multiply them like we did over here, right? So what happens is, if the base is same, terms are in multiplication, powers gets added up. If the base are same, terms are in division, we have to subtract the powers. Okay. So that is it for this session. I hope you get all these. Thank you for watching this. See you in the next part with our 1.2 subtopic.